Shalom and welcome. In this video, we'll be looking more deeply into the geometric mean with regards to right triangle. Okay, remember, geometric mean explores the root of the product of the two numbers in question. So there are some theorem, right triangle altitude theorem. It says that when an altitude is drawn from a vertex, the vertex where the right angle is in a right triangle, from that vertex down to the hypotenuse, which opposites to it. Of course, if it is drawn, is perpendicular to that altitude will be perpendicular to the hypotenuse. So another 90-degree angle will be formed there. So it is saying when that happens, that the height, this altitude, is the geometric mean of the two segments that altitude divides in the hypotenuse. So this means that h is the altitude, is the geometric mean, h, which is the altitude, is the geometric mean of D and E. Okay. All right. The other part of it, the second part of the theorem says that the two legs of the big triangle, each one of them is also a geometric mean, but to different sides. So, for example, segment A here, if we notice, it is the long leg of the large triangle, but it is also the hypotenuse of this medium triangle. The drawing of the altitude creates three similar triangles: the larger original triangle, the medium blue triangle here, and the small green triangle. And these three triangles are similar because each one of them is a right angle. They share 90-degree angle here. Okay, these two are adjacent to each other, share 90-degree, and then the large one has a right angle here. So this A is going to be the geometric mean of the whole hypotenuse, which is C, and the side or the segment part of this hypotenuse that is adjacent to A, which is E. On the other hand, the B, which is the hypotenuse of the small triangle, and the small side of the largest triangle, the B is also a geometric mean to the hypotenuse and D, which is the side of the hypotenuse that is adjacent to B. Okay, this will make more sense when we start applying it to problems. Right here, let's write out the geometric mean. Write out the ratios of each of these. Okay, again, this says that the height, the altitude, which is h, okay, that h, and maybe let's put the ratio first. Here we have the small triangle, which is the green one. The smallest side of the small triangle, which is D, which is AD, which is D, is going to match with CD, which is the smallest side of the medium triangle CD. This is the longer leg of the medium triangle. This is the smaller side, but also the longer side of the small triangle. So CD, which is H, gonna be the medium, the smallest size or the short size of the medium, and then the small side of the long leg of the small side. This is the small triangle, which is the long leg is going to be H also, and the long leg for this part is going to be DB, which is E. Okay, and if we check it here, they're going to match. Good. So this DC and DB. Okay, so now if we set up a proportion D actually let's write out to make it look more H. So H square is going to be D times E. Then H is equal to the square root of D times E. And that is what the theorem is saying, that H, which is the altitude, is the geometric mean, and this is the formula for geometric mean for D and E. Alright, the other two legs, A, you do the same thing, right? A and A. So A is going to be the geometric mean of the hypotenuse, which is C, and the side of the hypotenuse that is adjacent to A, which is E. So it's going to be C and E. Sorry. Okay, so A square is going to be CE. And then we do the same thing for B. So B equals B over. So it's going to be the same thing, equal to the length of the hypotenuse and the D, the side that is adjacent to B. C over D. I'm going to draw a line to get this off. So B squared is equal to C D. And then if you take the square root of A, then that will give you CD. And we can actually use this to prove Pythagorean theorem. We will do that later. Alright, let's look at a problem. Z is the geometric mean between blank and blank. Thus, Z equals what? So we look at the diagram. Look at Z. Z, there's the big triangle, right triangle. So Z is the altitude that drops down from the vertex of the right triangle down to the hypotenuse. So Z, then Z should be the geometric mean of 7, 7, and 2. So E is the geometric mean of 7 and 2. Therefore, Z is going to be the square root of 7 times 2, which is the square root of 14. There's no perfect square that can go into 14. So that would be the answer. The next, X is the geometric mean between blank and blank. So we look at X. So X is one of the legs. So the legs will be geometric mean to the hypotenuse. So let's find the length of hypotenuse is going to be all the way. So it's going to be 2 plus 7, which is 9. Then the geometric mean is going to be 9 and 2, because 2 is the part of the hypotenuse that is adjacent to X. And so it's going to be 9 times square root of 9 times 2, which is, split them, square root of 9 times square root of 2. Well, 9 is a perfect square, which is 3, square root of 2. Done. Okay, C, Y is the geometric mean of blank and blank. Okay, Y is the other leg, so it's going to be the hypotenuse and the part of the hypotenuse that is adjacent to Y. So 9 and 7. So it's going to be 9 and 7. So it's going to be square root of 9 times 7. So which is square root of 9 times square root of 7. Square root of 9 is 3, and then square root of 7. Okay. All right, let's look at another problem. So here we asked to find the values of x, y, z. Okay, we look at the x, y, z. Here we have a right triangle, and the altitude is x. The two legs, y and x. Okay, so yeah, sorry, something missing here. So this is 4, this is 2, this is 4. Okay, so then using the theorem y, and we can just write this out, that we know y is going to be altitude. Just write out the altitude line and then we fill them out. So, and then x, and then z, so there's another altitude. Okay, so here y is the altitude of the hypotenuse. So 2 plus that is 6. So it's the square root of the hypotenuse, which is 2. The hypotenuse, which is 6. And the part of the hypotenuse that is adjacent to y, which is 2. So, and x is the altitude. So it's going to be the 2 parts of the hypotenuse, which is 2 and 4. And for z, it's going to be one of the legs. So it's going to be the hypotenuse, which is 6, and the part of the hypotenuse that is adjacent to that, which is 4. Okay, now so let's solve. We can do y squared is equal to 6 times 2. So y is the square root of 6 times 2, which is, okay, 6 and 2 are not perfect squares, so 6 times 2 is 12. And then we can find the prime factorization of 12. So which will give us 12, 2 can go 6, 2 can go again 3. So it's 2 times 2 is 4. So it's going to be 4 times 3. So which would be the square root of 4 times square root of 3. Square root of 4 is 2 and square root of 3. So that would be your y. Okay, and then we look at x. Again, x squared, x times x is x squared, is equal to the square root, so we shouldn't put, if we put x, then we don't put square root. So x is going to be square root of 4 times 2. So x is equal to square root of 4 times square root of 2. So x is equal to square root of 4 is 2 square root of 2. Down to z, so z squared is equal to 6 times 4, but z takes square root of both sides, 6 times 4. So we have square root of 4 times square root of 6. And square root of 4 is 2 square root of 6. So there's no perfect square that can go into 6. And that's it.